G'day guys, just going to be doing the answers for the financial and recursion SAC Part A. This is the multiple choice one. Okay, so we'll get into it. I can't put the calculator, especially the financial solver, on this program. So what I'll be doing is just trying to provide as much working as I can. All right, so you guys can follow along as well if I'm using it. So we'll get into it. Question 1. We have an appliance repairman who charges $80 to turn up. Okay, and then $55 per hour. Okay, working time to make home visits. The recurrence relation that models this situation is, I'm just going to zoom in a bit. All right, so we know our initial amount. Okay, so really important, guys, when you're reading these questions is just taking in the key information. So we see that his initial amount's $80, or the initial amount of the repairman. Okay, and then every hour is $55. Okay, there's no other information than that. Okay, so it's an arithmetic sequence. Okay, we won't be multiplying at all. Okay, so what I'll do is I'll just cross out the wrong answers. So any multiplications I'll get rid of. Oop. There's a minus 50 here. Okay, and then this one here starts at 55. So the answer for the first one is A. Starts at $80. Okay, to get the next term, we're just adding 55 each time. Cool. Question 2. The population of a small country town has been decreasing. So I'm just going to zoom out a little bit. Has been decreasing by 8% per year since the beginning of 1996. Okay, then we know the value is 4,232 at the beginning of 1998. Okay, the population of the town N years after 1996 is given by. All right, so if it's decreasing by 8%, I'll just do that. Okay, we haven't been given the initial amount. We've just been told after 2 years, okay, so the beginning of 1998, the population goes down to 4,232. Okay, what it wants is the population of the town N years after 1996. Okay, so if it's ever asking after N years, okay, essentially it wants the nth term rule. Okay, and because this is geometric, we can tell by this that it's geometric. Right, geo. Okay, we want the nth term rule of the geometric sequences. Okay, so that rule is Vn equals 1, and in this case it's decreasing, so 1 minus percentage on 100. Okay, the power of n times the initial amount. Okay, because we know it's decreasing by 8%, if you want to sub that 8 into this part here, you can do that. As a common ratio, you know that that's going down to 0.92. Okay, still to the power of n, because they haven't been told the number of years. All right, and then the initial amount. Okay, don't get confused thinking that the initial amount was 4,232, because that was actually at the beginning of 1998. In the question, it wanted it after 1996. Okay, so we don't know what the initial amount was, but just looking at our other answers, all the rest have 5,000. Okay, so we're going to go with 5,000. If we wanted, we could have, increased this 4,232 by 8% once, then 8% again. Okay, it should get us back to 5,000. Okay, but by looking at that, our correct answer is C. Initial amount 5,000. Okay, and we're timing it by 0.92 to the power of n. Okay, question 3. There are 300 newspapers to be sold each day by a newsagent who opens his shop up at 6 a.m. Okay, he sells 120 newspapers in the first hour, and the sale decreases by 25% each subsequent hour. in how many hours would the newsagent be able to sell all his newspapers? Okay, so he needs to sell the 300. I'm just going to highlight that. Okay. And so he's opening up his shop at 6 a.m. Doesn't matter too much, but we are told that he sells 120 in the first hour. So just write hour 1. Get the right pen. So hour 1, he sells 120 papers. Okay. And then we're going to work out to the point which this newsagent finally sells, how many hours it'll take them to finally sell the 300. Okay, it's going to want it to the nearest hour because we can see those answers 2, 3, 4, 5, and 8. Okay, to the nearest is the nearest hour. Okay, so what we're going to do is apply a 25% decrease to this 120. Okay, you think of a decrease, guys. We're going to be minusing that percentage. 100 is going to be 1 minus that. Okay, so if you want to sub that 25 in, okay, it's going to equal a common ratio of 0.75. Okay, so what I'm going to do is apply that 25% decrease to the for each hour. So I'm going to times it by the 120. All right, and this is how much he's going to sell in the second hour. Okay, it's 90. I haven't set this up very nicely, but 90. Okay, and then again, because we've got a common ratio, that's going to add in total. I'll write it, the totals over here, 120. Okay, going to add the 90 is 210. Okay, then I'm going to still do this common ratio of 0. Need the highlighter. 0.75. Okay, I'm going to times it by the 210 now. Sorry, not the 210, the 90 up here. So 0.75 times 90. All right, that works out after the 3. Okay, the number of papers he sells after 3 is 67.5. Okay, so I'm going to add that again onto the total. So it's going to be 75.5. Okay, and it's most likely going to be in this 4th hour. Again, I'm going to do, because we're trying to get to 300, I'm going to do that 0.75 now times the 67.5. So I'll just highlight that. I'll just write the 1. So my working's a little bit all over the place. That's the 1 hour, that's 2 hours, that's the 3 hours. Okay, so I'm doing the 0.75 times the 67.5. Okay, and then this time, this 4th hour, he sells 50.625. Again, they're not whole numbers, but it's still going to get us over that 300. So what's that, like 320 something? All right, so it's going to be after the 4 hours. All right, 320. It's a bit over that, but that's it for C. In terms of the recurrence relation, I wonder if you could do that using the nth term rule as well. I'm not sure if anyone tried that, but you might be able to do it using the nth term rule as well. Solving for n when you want it to get to 300. Okay, so that way may work as well. Okay, whatever. I find with recursion finance, guys, doesn't matter how you do it as long as you get the right answer. Okay, obviously you want the quicker way as well though. But question 4, okay, an amount of $2,000 is invested earning compound interest at the rate of 5.4% per annum. Okay, compounding quarterly, the effective annual interest rate is closest to. Okay, so we just want the effective interest rate. Okay, the easiest way to do this, guys, is on the CAS calculator. Okay, so imagine you're looking at your CAS calculator, you'll press menu. Okay, go to 8 finance and then 5 interest conversion. Okay, and then 2 the effective interest rate. So you'll get this EFF bracket. I think you can type it in as well. But put the nominal rate in. Okay, and the amount of times it's compounding. All right, and I get an effective interest rate of 5.51%. Okay, so that's closest to D. 5.5. Cool. All right, question 5. A brand new van is depreciated at the rate of 26 cents per kilometre travelled. Okay, after having travelled a total distance of 80,000 kilometres, it is valued at 13,700. Okay, the purchase price of the van was. Okay, so a few things in this, guys. We know it's unit cost because the van is depreciating at 26 cents per kilometre. Okay, we know the distance the van travelled. Okay, so how many kilometres? In this case, that's going to stand for N. All right, so I'm just going to try and highlight that. $80,000, that's going to stand for N. Okay, and then after that number of kilometres, it's going to be valued at the 13,000. So if I was just to write in this 26 cents is going to stand for our D, or the difference, how much is going up or down per kilometre, in this case down. This stands for N, the 80,000, okay, and the 13,700 stands for the value after a certain period of time. Okay, the purchase price of the van, that's going to be VO. Okay, so what I'm going to do here, unit cost is a type of arithmetic sequence. I can use the arithmetic nth term rule and just fill in the values. So that's Vn equals VO. Okay, in this case minus because it's depreciating. N times the difference. Okay, and I'm just going to plug in those values we know. So we know it's 13,700. We don't know what VO is, minus N. 80,000 times the difference. And because it's 26 cents, just make sure that's 0.26. Okay, and then in the calculator, guys, we're going to solve for that VO. So I'm just going to go down a little bit lower, but solve, bracket, write all that in. If you want to just put V, that's fine. Okay, and comma V, whatever letter you want to use, that's fine. We'll do that in the calculator now. All right, I think this is probably the easiest way to do this. So guys, make sure in the test you know all the different types of sequences like unit cost, simple interest, flat rate depreciation, all that sort of stuff, and whether it's arithmetic or geometric. Okay, compound interest, reducing balance depreciation, all right, so on. I'm just whacking this 80,000 times 0.26. Okay, comma V. Control Enter. All right, I've got a value of 34,500. Okay, so that works out to be D. Sweet. Moving on. Question 6 and 7. Okay, Kelly's invested $30,000. Okay, in a term deposit that earns 4% per annum, compounding quarterly. Okay, the recurrence relation that models this investment is, okay, so we know the investment amount's 3,000. Okay, and we can see each of our answers for VO equals 3,000, so that's fine. Okay, the next part is we know it's earning. interest at rate of 4% per annum. Okay, and the next part that it's compounding quarterly. Okay, so we're going to have to take that into account. Okay, so what we need to do is we need to find the R value. Okay, so what that common ratio is. Okay, and that's just going to be, it's going to be 1 plus because it's earning interest. The percentage on 100. All right, this percentage is per compound. Okay, so we know it's 4% per annum, but it's compounding quarterly. So we've first got to divide that 4 by 4. So the 4% divided by 4. So it's going to be 1% per quarter. Okay, and then I'm going to put that up into the percentage. So it's going to be, the 1 plus 1 on 100, which is going to equal 1.01. All right, so that's our common ratio. That's what we're going to be multiplying by at each quarter. Okay, and with our occurrence relation, that means it's going to be E. Cool. Moving on. Question 7. Okay, after 2 years, Kelly has. Okay, so we want to find the value of the investment after 2 years. It's a geometric sequence, guys. So you could do this on your financial solver if you wanted, but I'm just going to use the geometric nth term rule. Okay, so Vn equals, so we want to find the value after 2 years, so it's going to be 3,000 times our common ratio, which we know is 1.01. Okay, to the power of n. Okay, in this case, guys, the n isn't 2 though, because there's 4 quarters in a year. We want to know after 2 years, so it's going to be to the power of 8. Okay, so you can put this straight in your CAS and that'll get the value. All right, and that equals 3,248.57. All right, which rounds up to B. Cool. All right, question 8. Okay, a fixed amount of mustard. I was about to say a fixed amount of money. Okay, is invested in an account that earns compound interest, calculated yearly. Okay, no other transactions occur in this account. A graph is showing the amount in this account each year after the initial investment is made. Okay, so there's 2 key bits of information just in the question there. We've got a fixed amount money invested. Okay, so after 0 amount of time, there should be money in the account. Okay, and the second thing is that it's compound interest. Okay, so compound interest essentially means multiplying. Okay, so it should be going up. All right, with a curve, going up with a curve. So if we go through these, it looks like A is the only correct one. Okay, but because it has that initial amount invested, okay, it's going up and it's curved as well. Right, so it's the only one that shows that. Cool. Question 9. Okay, so we've got a bit of a scatter plot here. We see an investment or the value of something started at $12,000. Okay, it's going down in value. Okay, it's not going down just by looking at it. We can see it's not going down by the same amount. Okay, so it's going to be some sort of reducing balance. But we'll have a look. Okay, the graph above could show the value of a truck depreciating at a flat rate of 8% per annum. Okay, so we know if it's depreciating at 8% per annum, we're going to have an R value of 0.92. Okay, just if you don't know how to do that, it's 1 minus the percentage, 100, the percentage in this case being 8. Okay, it'll work out to be 0.92. So what I can do with this 0.92 is I'm going to multiply it by just the first value. Okay, see if it equals the 10,960. Okay, and then I'm just going to keep doing it to make sure it's going to equal the values after. So 0.92. Okay, make sure you don't just fall for it being like the first one and thinking it's right. Okay, I've got $11,040 anyway, so that one doesn't work. Well, I might just cross these ones off as I go. Okay, an annuity with annual payments made of $2,000 to the investor, an interest rate of 8%. So that one should be going up a bit. We've got an interest rate of 8%. It's an annuity, so it's an investment. Okay, they're also making... Oh no, they're receiving $2,000 from it. Okay, so for that one, it's going up at a rate of 8%. So we can have a common ratio of 1.08. Okay, times the VM before. Okay, and then 2,000 is being made to the investor. All right, so I'll just quickly do that. I'm going to do 1.08 on the calculator times the 12,000, the initial invested. Okay, equals minus $2,000. Okay, and that in fact does equal, I might just rub out everything I've done so far. That in fact, if it's going to let me rub it out. Okay, that does equal the 10,960. So I'm going to do that again. I'm going to times that 10,960 by the 1.08 minus the 2,000, see if that works. Control enter, minus 2,000. All right, I've got 9,836 and 80 cents. Okay, so they haven't got the cents here, but that is looking good so far. I'll do it one more time. Okay, so that in fact did equal this one. Okay, so I'm going to do it one more time. I'm going to times that 9,836 by the 1.08 minus the 2,000, and then I reckon... I'll do them all. It's pretty important you do. It should be like that though. Times 9,836 minus 2,000. 8,200. 8,600 and 23. Okay, so it's looking pretty good. It did work out to be that one as well. So far I'll go with B. Okay, a caravan depreciated using a reducing balance method at 8% per annum. I just realised I did reducing balance for the first one. Okay, you'd be timesing by the 0.92. A flat rate, my bad, you'd be depreciating by whatever 8% of the 1,200 is. Okay, but it's not going to be C anyway. Okay, a perpetuity doesn't change in value. Reducing balance loan with annual repayments. Okay, we've got it anyway at B. Okay, so we'll move on. All right, question 10. Tom invests $5,000, okay, at 8% per annum. Okay, have simple interest for 4 years. Okay, as he hopes to go on a holiday. Okay, the amount he will have available to spend after the investment period is... Okay, so with this one, guys, again, just taking in the key wording. So this is our initial amount. Okay, we've been given the percentage. Okay, it's simple interest as well, so it's going to be arithmetic. Okay, and that goes on for 4 years. Okay, and then we just want to know what the value is after the 4 years. Okay, so what I've got to do, because it's simple interest, I've got to find out how much that actual value is. So what 8% is of 5,000. So, and that'll tell us how much is going up each year. So it's just the percentage on 100 times, oops, it's probably not going to show up for you, but I'll times the initial amount. Okay, and I think like in your textbook it says to find the value of D. All right, so that's just 8 on 100 times 5,000. Okay, so that equals $400. Okay, so each year it's going to be going up $400. That goes for 4 years. So I'm going to times that by 4. So that's going to be $1,600. Cool. Add on the initial amount. Okay, it'll be $6,600. All right, so it's E. Cool. All right, question 11. Ted wants to accumulate at least $300 interest by investing $5,000 for a year. Okay, if interest is compounding monthly, the interest rate per annum he would need is closest to. All right, this is probably the first question I might do on the financial solver. Okay, so if you don't know how to do the financial solver, I'd go menu, finance, financial solver. Okay, the reason I'm doing this on the financial solver, you can do it tech-free, okay, is just because I've got a few things. We've got an interest rate that's compounding monthly. Okay, so it's going to be, it's happening, like this compound is happening 12 times, obviously, within the year. Okay, we want to find, he wants at least $300 interest, okay, by investing that $5,000. So we know what the initial amount is at $5,000. We know he actually wants to gain $300, so that he wants the final amount to be $5,300. Okay, so it's going to be easiest doing this on the calculator, all right, the financial solver. Okay, so what I'll do is I'll just put in all my values. My value for N is 12, because it's just after 1 year. All right, we want the annual interest rate too. Okay, so that's what we're trying to find, which works well with the financial solver. Principal value is 5,000. Okay, payments is 0. There's no payments made to, he's not receiving anything either. Okay, the final value, oh, it's meant to be an F. That's really bad. Final value equals 5,300. And CPY equals 12. All right, so I'm just going to put that in the calculator, financial solver. Just one thing I did not write also is the principal he's invested at, so that should be negative 5,000. Okay, so if you're ever investing or you're ever making payments, okay, those values are negative because you're giving that money away essentially. Not giving it away, but getting rid of it is how I like to think. All right, 0 final value. All right, so it's taken me a while to explain this. If you could do this on the financial solver in about a minute or so. I've just been explaining it, but you could do this pretty quick on the financial solver. It's so good. Once, like if you've got the hang of the financial solver, it's so good. Okay, so that works out to be 5.84%. Question 12, the recurrence relation, okay, starts at $1,200. To get the next value, I'm timesing by 1.2, okay, and then adding $300 onto it. Okay, this model is an investment over time. Which of the following is not true about this investment? So before I even look at what's not true, this person's invested $12,000. Okay, it's compounding at a rate of 20%. Okay, because it's 1.2. Okay, and they're also making payments because it's adding on 300. They're also making payments of $300. Okay, it doesn't say if it's monthly, yearly, whatever. Okay, which of the following is not true? Okay, so A, the initial investment is $1,200. That's correct. Let's give me a mark. The investment after 3 periods of time is $3,165.60. Okay, I might actually do that. So what I'm going to do is I'm going to start at this $1,200, times it by 1.2 and add 300. Okay, I'll do that once. So 1,200 times 1.2 plus 300. Okay, so I get $1,740. Then I've got to do it 2 more times. Okay, so that value again times 1.2 plus 300 times 1.2 plus 300 is, yeah, $3,165.60. So B's also correct in terms of like it's right. C, $300 is added after each period of time. Yep. The investment doubles at the end of the second period. So that means from $1,200, and it's lucky because I did this in B. So after the initial amount was $1,200. After 1 year, it was $1,740. Should put dollar signs there. And then after the second year, because it wants it after the second period, it was $2,388. Okay, so comparing those two, you can see that it's not quite doubled. Okay, so D, I reckon, is the one that's not true. Okay, E, the investment is not a linear model. Okay, the investment's both geometric and arithmetic because it's been timesing by 1.2, but there's also additions of 300, so it's a mixed model. All right, so moving on, question 13. Aileen started with $900 in a super account. She decides to invest $900 each month into this account. There's returning an interest rate of 5.75% per annum. Okay, compounding monthly. How much would she have to retire on after 25 years? Okay, so fair bit of information here, guys. We want it after 25 years. Easiest way is just going straight up to the financial solver. Okay, so we want to know the value, the final value of her investment after 25 years. So again, easiest way is just straight to the, don't even bother doing this with recursion. Just go to the financial solver. All right, so I'll write in all the things. So the value of N, okay, we've got 12 compounds. It's compounding monthly. Okay, we want that over 25 years, so 12 times 25. The annual interest rate, we were told, is 5.75%. Payment value. Okay, she's also making extra additions. Okay, she's also making extra additions each month of $900. Okay, so that's extra additions of $900, so a negative 900. So I've just written that for the wrong thing. The principal. Yeah, the principal still, that worked out nicely. She invests $900, and then the payments each month are also $900. All right. The final value, we don't know. Okay, payments per year. Compounds per year are 12. Okay, so I'll put all those in to solve. Just with your financial solver, guys, make sure a couple things that you see enough decimal points. Okay, especially if you're doing the financial solver over like 2 or 3 different parts. Okay, because if you don't have enough decimal places, then you might end up being a few decimal places or a few dollars off. Okay, so you want to make sure that you've got enough decimal places on your calculator. Okay, you can change it in your settings, like your document settings on the float. I've got mine set to 12. Okay, which that gives me plenty of decimals as well. Okay, so the final value I've got as 604,017 and 31 cents. 604,017 and 31 cents is going to be E. Cool. All right, it's gone up a heap. But you think about that, it makes sense. She's doing extra additions of 900 each month for 25 years. So 9 times 12, then times 25. And then she's also got a really good interest rate of 5.75% compounding monthly. Okay, so a fair bit being added on there. Okay, question 14. Riley invests $8,000 in a bank at 5.15% per annum. Okay, interest is compounding quarterly. All right, I might just highlight these as I go. Invest $8,000. There's the interest rate, compounding quarterly. Okay, at the end of each quarter, he adds a sum of $450. Okay, so making payments. Okay, after interest is paid into his account, the amount in his account at the end of the third quarter, after he has added in the $450. Okay, again, just probably easiest to do this in the financial solver. Okay, the value of N. So what we're doing is he's invested $8,000. We're trying to find after the third quarter. So that's just after 3 payments. Okay. Yep. Because it's not even a year yet. A year is 4, so it's just 3 payments. The interest rate, when I was 5.15. Principal value, he invests 8,000. Okay, so negative 8,000. Payments, I was also making payments of $450. All right, the final value we want to find. Okay, and then payments per year, compounds per year. Just be careful, guys, with payments per year, compounds per year. I'm just getting the habit of thinking it's always 12. Like people think that these ones are always the most important, but then just keep the 12 as the payments per year, compounds per year. Okay, so just be careful, be thorough with that. Okay, because that's where you get mistakes. The mistakes also with the negatives as well. Like whether it's negative, whether it's positive. My calculator's set in exact mode at the moment. I'm getting the most horrible fractions. Final value 4. I'm pressing Control Enter for my answer, so. Okay, I've got $9,680 and 45 cents. Okay, so that's B. Okay, Shelley's got another investment of $45,000. Okay, 4% per annum. Okay, 5 years compounding annually. Okay, the total amount of interest earned is closest to. All right, so this is probably something that's a little bit different. We're going to use the financial solver again. Okay, the interest earned, though, in this case is going to be, there's no extra payments made, so it's just going to be the final value of the investment minus the initial value. Okay, this isn't a rule in your book or anything, but we don't have to take away any payments or anything because payments aren't being added. So the interest is simply just going to be whatever the final value is minus just the amount she invested. Okay, but we do have to find this final value. Okay, and we're going to use the financial solver again. Okay, so the value for N is 5 years and it's compounded annually. Okay, so just 5. It's just going to be a 5. Interest rate equals 4%. Principal value 45,000. Payments, there's none made. Final value is what we want to know. Okay, and then compounds per year. Payments per year equals just 1. Cool, so we'll put that in to find the final value. Okay, again, I've made a mistake just with the investment. That's a negative. It's a really easy mistake to make. No payments. Okay, final value you want to find. Okay, so I got the final value as, 54. Just need the right pen. Go away, please. Final value equals 54,749 and 38. I think, which resembles this E answer, but that's our final value. Okay, so I need to take that away from our initial amount. Okay, so I'm going to do 54,750 minus the 45,000. Okay, so that'll work out as D, 9,750. Cool, sorry, I shouldn't be using red if you're colorblind. I actually have a friend who's colorblind to red, so I shouldn't be using red, but I will keep going. We're up to question 16. We've got a reducing balance loan. Okay, they have a loan of $25,000. Okay, interest is being charged at 6.8% per annum. Okay, repayments of $160 are made each month. Then the amount to the nearest dollar still owing after the first payment is closest to. Okay, again, you could do this via recursion. I just whack it in the financial solver. Okay, so the number of payments, it wants to know what the value of the loan is after just the first payment. Okay, so we're just going to do it as 1. What was next? The interest rate. Okay, 6.8% per annum. This is a loan. Okay, so this one's actually going to be a positive value of 25,000. So I'm writing this out, and it probably looks like it's tedious, but if you're in your financial solver and you're just whacking these in, like these take you 30 seconds, a minute to answer. Okay, there is a payment being made of 160. Final value. What else? The final value is what we want to find. Okay, and then the payments per year. Compounds per year. Okay, in this case, guys, it says 6.8% per annum, but he's actually making, or this person is making repayments of 160 each month. Okay, so there's 12 payments per year. Okay, so that's going to be with the compounds as well. Okay, so I'll whack that in the calculator. 6.8. Couldn't imagine much has gone off his loan. Not sure why he's so interested, but wouldn't have gone down much. Okay, so it is. So I've got a negative value because it means he's still got to pay that. 24,981. And it's 0.66 recurring. So that works out to be 981. That works out to be A. Gee, that is a rough. That is rough. He's only paid $19. Yeah, that's terrible. Poor fella's just got a terrible interest rate there. And he's not paying much, so. Yeah, that's right. Question 17. Okay, Julian borrows $360,000. Okay, to purchase a business. He will fully repay the loan after 15 years. During the first 7 years of this reducing balance loan, the interest is 5.15% per annum. Okay, compounding monthly, and Julian makes monthly repayments. Okay, during that last 8 years of the loan, the interest rate goes up. Okay, to 5.4% per annum, compounding. And it's monthly, because Julian's making monthly repayments of $2,900. Okay, during the first 7 years of the loan, Julian's monthly repayments were closest to... Oh, right, okay. So we need to do this. It's going to be in two parts, guys. Okay, Julian borrows $360,000. Okay, but it's going for 7 years, all right, at an interest rate of 5.15%. Okay, and then he finishes off the last 8 years, okay, at 5.4%. So what we need to find is I'll highlight the things we know. Okay, the question wants us to find the monthly repayments, okay, in the first 7 years. All right, so what I'll do is it's most likely we're going to have to start with the 8. Okay, but I'll just fill in all the information we know. So this N, just at the 7 years, okay, it goes for 7 years, and the interest rate is compounding monthly. Okay, so I just want to highlight that. So times 12. Okay, the principal value. Sorry, I've just got to get up on my financial solver. Is how much they've borrowed. Oh, sorry, the interest rate's next. Okay, that's 5.15. All right, so don't be scared by these bigger questions, guys. If you see a bigger question, most likely it's going to be a financial solver. Okay. All right, so the principal value, he borrowed 360, okay, because he borrowed it, means he's received that money, so it's positive. All right. Okay, and I'm writing this all out, but if you do this I actually think it could be a worthwhile thing if you're not confident with it to write it out if you want. Otherwise, you can just do it straight in your financial solver. Payment amount is what we don't know. That's what we want to find ultimately. So I'll highlight that bad boy. Final value. Okay, we don't know what the final value is after the 7 years. Okay, so with 2 question marks, we won't be able to find this, but CPY, PPY is 12. Okay, so we're going to have to use this 8 years to help find the initial amount. Okay, then find the payments, because the initial amount of the 8 years one is going to match up with the final value after the first 7 years. Okay, so this 8-year one is going to be 8 years and still compounding monthly. Okay, the interest rate had changed at 5.4. Principal value, this is what we'll want to find. Okay, payments. All right, we're told he's making monthly repayments of $2,900 in this section. Not sure why I put a dollar sign there. Payments, final value. Okay, we are told his loan gets to 0 because he's going to fully repay the loan after the 15 years. Okay, and this interest rate was still compounding monthly. Okay, so what I'm going to do, guys, is in my financial solver, I'm going to put this information in first. Find what this final value is. This principal value is. Okay, I might just do that first. Do one step at a time. So 8 times 12. 5.4. Principal value, we don't know. Payments. The payments, I did this before too. The payments, he's paying it back, so it's a negative 2,900. Final value 0. 12 and 12, cool. All right, so this works out to be, might just rub out this part, if it'll let me. Okay, so the principal value worked out to be 22,000. 5659 point. If you want, guys, you can press like actual Control C on your calculator to copy this information over. Okay, so rather than writing it all down and writing it all out, you can copy it. I'm just going to get enough decimals so that I'm closest to. Because this is a multiple choice one, I'm not fretting too much over the decimals because I'll get one closest to it. All right, make sure you include all the decimals for a short answer question. Okay, because you don't want to be like 1 cent off. Okay, so this value, this 225,000 now becomes the final value in here. All right, because it's the final value as well, guys, Julian's still going to owe this amount. Okay, so when I put it in the final value in the next one, I'm going to actually have it as a negative value because he still actually owes that amount. Okay, if you put it as a positive, that means, it means it's going to be like a $500,000. You have to put that as a negative. All right, interest rate 5.15. There are some things that doesn't matter where you put negatives. So, but just having an understanding, okay, of what should be negative, what shouldn't, is important. Payments, we don't know. Final value. Okay, so this looks like I've done a lot of work for this question. Yeah, because it's two-part, I have, but the more practice you have with these questions, guys, like you're definitely going to see it on your exam. All right, you'll probably even see a three-part question. Okay, the more exposure you get to them, the better you get at them, the more confident you are with them. Okay, so I've got the payment amount is $2,877. So it's A. All right, so a fair bit of financial solver stuff. Okay, a computer originally cost $2,385. This is question 18. If it depreciates at 15% per annum on the diminishing value, its value after 3 years will be. Okay, so this is not too bad a question. All it wants to know is we know the initial amount of a computer. Okay, it was 2,385. Okay, and it's depreciating at the 15% per annum. Okay, so every year it's just going down 15%. As an R value, okay, that's 0.85. Okay, if you want to do that 1 minus percentage on 100 thing, that's fine as well. All right, so all I'm going to be doing is finding what its value is. On the diminishing value. Yeah. So it just means on that diminishing value, it just means it's going down 15% per annum. Okay, and then 15% of whatever that diminished value is, and then 15%. So I'm just timesing it by 0.85 3 times. Okay, will get me the value. Okay, so if you wanted, you could do it all at once, times 0.85. You do that 3 times, or just to the power of 3. 5. Okay, so that equals 14, 64, and 69. Okay, so that's C. All right, question 19. Jane borrows $80,000 for 10 years at 5.6% per annum compounded monthly with monthly repayments of $555. Which of the following is true? Okay, the loan will be paid out in 10 years. So what I might do is I'm going to actually put this information in the financial solver. Okay. And I don't reckon the first one, maybe the first one will work out, but one of them will work out by using the financial solver. So I've got Jane, she's borrowed $80,000. Okay, it's gone for 10 years. So N's going to equal 10. All right, and it's compounding monthly. I've just got to get up on my calculator. Okay, the interest we've been given, the annual interest rate, 5.6%. The principal value is just how much Jane borrowed. Okay, so that's a positive value because Jane's received that. Okay, payments to start off with. Oh, yep, it's monthly repayments as well, so we know that. So she's paying back $555. The final value, we want to know if that's going to be 0, just for A. Okay, PPY. So for this one, it's just trial and error until you get the one that works. It would be really nice if we got it as the first one. Guess if you want to skip ahead, that's fine. Just putting it in the calculator, final value. Okay, so I've got the final value as she is still owing $50,000. Okay, so A is not correct. Okay, weekly repayments of 150 compounded weekly would reduce the period of the loan. Weekly repayments for 150 compounded. Okay, so what that would do, guys, is that would change this payments per year, compounds per year to weekly. All right, so that is 52. So I'm just going to rub this out. If it'll work, please, eraser. Yep. Okay, so that's going to become 52. They're still going for 10 years, but now that compound weekly is going to change this monthly, the 12, to also 52. And I've got to change the payment amount as well. So from, instead of paying back $555 every month, come on, that's a really bad razor. She's now paying back, what is it, 150. Okay, so I'm just going to find out this final value. I'm going to see if it's less than what I just found it out as, 50,866. So if it's less than 50,000, then it's, or 50,800, it'll be good. All right, so that reduces it. So the final value of the loan over the same period of time doing this, the loan's gone down to 35,000. So thank everyone that we could do that with B. Cool. Yeah, I'll just move on. Once you got the answer for that, definitely move on. Question 20. Okay, electrical equipment is purchased for $15,000, depreciates by 20% per annum using reducing balance method. The total depreciation of the equipment after 4 years is. Okay, so we've got the initial amount of our electrical equipment is 15,000. Okay, it's depreciating, so it's going down. So to find the R value, if you want to do that 1 minus percentage on 100, that's fine. Okay, put the 20% in. You're going to get an R value of 0.8. Okay, and there's nothing else that's happening in this. So what we've got to do is find what the value of the electrical equipment will be after 4 years. So after 1 year, you could do it by recursion times 0.8 times 0.8 times 0.8 times 0.8. But I'm just going to use the geometric nth term rule. Okay, so the initial amount times the R value, okay, into the power of n. N in this case is the 4 years. All right, and I'll put that in the calculator. Okay, so reducing, just if I've lost anyone there, reducing balance, guys, it's a geometric sequence. So use that geometric rule. Okay, this will find the value. It's gone down to 6,100. Now, just be careful for asks. Yeah, it's asking for the total depreciation. Okay, so it's gone down to this, but the depreciation is actually the difference. Okay, from $1,500. Okay, and it's gone down. It's the difference between the two, so 6,144. Okay, that'll be the total depreciation. If it asks what's the depreciated value after 4 years, okay, it's the 6,144, but let's know how much it's gone down, which should be 8,856. All right, 21. Josh makes an investment of $2,500. Okay, in an account that pays 6% annual interest, okay, compounded monthly. The time in months that it will take for the investment to double in value can be found by solving. All right, so a couple of things here. I'm just going to highlight. We've got an investment of $2,500. Okay, we've got the annual interest rate, but just note that that's compounding monthly as well. The time in months it's going to take, so we want to find the value of n for the investment to double. Okay, so if it was $2,500, we want to know when it's going to hit $5,000. In value can be found by solving. Okay, so again, guys, this is the geometric sequence. Okay, the easiest way to do this is just using the geometric nth term rule. Okay, so Vn equals VO times R to the power of n. Okay, we've first got to find out what R equals. All right. U, which is 1, and in this case it's increasing value. 1 plus the percentage on 100. Okay, that percentage though is per compounding period. Okay, so you can't put the 6% in there. That 6% you first got to divide by how many compounds there are, which is 12. Okay, so that's going to be, should be 0.5. You put things in the calculator, just double check, make sure it's 0.5. Okay, so that is what I'll put in here. So 1 plus, actually I won't write it out. So it's going to be, I'll just do it straight on the calculator. 1 plus 0.5 on 100. Okay, so our R value equals 1.005. All right, so that's one portion to it now. We wanted to find when the investment doubled in value. Okay, so that investment's going to get to $5,000. Okay, the initial amount of the investment was $2,500. Okay, times 1.05. All right, we want to find how many years that, months. Yeah, because it's happening monthly. It's the number of months that's going to happen. All right, if we look at our answers, we don't actually have anything that resembles that. Okay, but just a simple understanding, if we're trying to find n, we could divide both sides by 2,500 here. Okay, so obviously 5,000 divided by that 2,500 is going to be 2, which leaves the 1.005 to the n. Oh, sorry, they've used t, but it doesn't matter. Which works out to be a. Cool, moving on. 22. A personal loan of $70,000 is paid back over 20 years. Okay, we've got the interest rate, 6.8% per annum, reducing balance worked out quarterly. The quarterly repayments will be closest to. Okay, so this is just a financial solver question straight away. N's going to be 20 years. Okay, but we've got quarterly repayments, so times 4. Okay, interest rate. So you see how much you can do on the financial solver. Yeah, once you get the hang of it. What's next? Principal value. Just making sure you get the negatives and positives right. Borrowed $70,000. Payments. We want to find them out. Okay, it says the loan is paid back over the 20 years, so the final value is going to be 0. Okay, and compounds per year. Payments per year equals 12. Actually, no, it doesn't. Sorry, the payments per year, compounds per year equals 4. So I was a victim of my own thing there. You just get used to it always being monthly. compounds per year equals 4. All right, so I'm just going to put this on the financial solver. Skip ahead if you want. All right, so the payment amount I've got is $1,607.26. Okay, so A. What's that? Five questions left. All right, question 23. Okay, we've got an investment of $1,200, and for 1 year, it's going to return $140.38 interest. Simple interest per annum for this investment is closest to. Okay, so simple interest, guys. There's a rule for it. Okay, it's something like to find the difference. Okay, we use the percentage on 100. Okay, and times the initial amount. Okay, in this case, we know how much interest or the difference it's going up by each year. Okay, that's $140.38. $140.38. Okay, the percentage is what we're trying to find. Okay, so I'll have the percentage on 100. Okay, and we know the initial amount of the investment was $1,200. Okay, so what we're going to be doing is solving for that percentage. Okay, so on your calculator, just use your solve function. Okay. Just don't put a percentage in for there. Put P or X or something, because I don't think it likes when you put percentage. It might like. I just never do it, but so you go to your calculator. If you don't know how to use the solve function, go to the little book. Okay, you should have solve there. Okay, or you can type it in if you do it like that as well. Okay, but type it all in, can solve for the percentage. Alright, which works out to be 11.69, which works out to be D. I can just move that across. Sweet. Alright, question 24. Okay, Shire buys a new television. The advertised price was $2,700. He chooses to pay a deposit of $500 and then monthly repayments of $115 over 2 years. Okay, the amount of interest paid under this arrangement is closest to. Okay, so Shire bought a TV or got a loan to buy a TV for $2,700. Okay, so when we're thinking of interest, guys, how much interest is gained or paid? Okay, that's going to be the difference, how much it's gone up from $2,700. Okay, so with Shire, he paid a deposit of the $500 straight away. Okay, then also did repayments of the $115. Okay, over the 2 years. The $115 was monthly over 2 years. Okay, so 12 months in a year, over 2 years, that's 24 months. Okay, whatever this value is, okay, you'd expect it to be above 2,700. So the deposit plus 115 times 24. Okay, got 3,260. Okay, so the interest is the difference between this value and the initial amount. Okay, so you can do 3,260 minus 2,700. Okay, which will equal the 560. Alright, so that's C. Alright, question 25. A new computer costs $3,490. Okay, if depreciation is calculated at 33% per annum, okay, it's reducing balance. And the computer's book value at the end of 5 years will be closest to. Alright, so It's a geometric sequence, guys, so we can use the nth term rule. So Vn equals Vo times R, it's the power of n. Okay, R in this case it's depreciating, so it's going to be 1 minus percentage on 100. Okay, there's no compounding or anything, so it's just going to be 1 minus the 33 on 100. Okay, so it should equal 0.67. Yep, so that's our R value. I should have written that at the front. Okay, so what we want to do is find what the value is after 5 years. Okay, VO was 3,490 times our R value to the power of 5. Okay, just be careful obviously as well, guys. If this was happening monthly, your value for n, alright, your percentage, you'd have to be adjusting. Okay, I wonder if this is something that I think this is something you can't do in the financial solver as well, because financial solver doesn't like depreciation. Oh, no, it wants annual interest rate, which is not. Yeah, so I don't think you can do this in the financial solver anyway. But I'm going to put this in my calculator. Power of 5. Okay, so the value of the computer book, 47119. Okay, which is C. Okay, we've got 2 questions to go. Okay, a student borrows $2,000 at an interest rate of 12% per annum to pay off a debt. Okay, the loan is repaid by making 6 monthly payments of $345. The amortization table for this loan is shown below. Some of the information is missing. Alright. So, what we've got to do, question 26, the interest paid when payment 2 is made. Okay, so to find this interest in here, guys, just draw an arrow for it. What you've got to do is, it's going to be the interest is going to be the percentage per compounding period. All right. Per compound. Wait, there's an easy way of doing that. It's just going to be, there's definitely an easy way of doing it. It's actually going to be the difference of the 345 and the principal reduction. Yeah, so I can just do 345 minus that. But if I didn't have the principal reduction there, okay, yeah, I'll do percentage per compounding period on 100. Okay, times the initial amount, where the initial amount is the period before. Okay, that percentage per compounding period would be 12%, but there's monthly payments as well, so 12 divided by 12 would be that, just 1%. But anyway, I'll just do 345. Minus 285. Sorry, 328.25. Okay, equals $16.75. Alright, last question. The balance of the loan after 5 payments have been made. Okay, so to get the balance, guys, it's the previous balance. So this value here minus the principal reduction for the next one. So 680.37 minus the 338.20. which we get as 342 and $17. So C. All right, thanks for tuning in, guys. Hopefully it helped.